Let's solve this system of differential equations. So just to have it in a nicer form, I'm going to multiply by for the first equation and by for the second one. And instead of dx dt, just for shorter notation, just to write it faster, I'm going to write x prime. So it's not x to the first, it's x prime. So 4 times x prime equals 100 minus x, right? Because 1 over 4 times 4, it's 1, plus the same thing here, 1 over 4 times 4, it's 1, so y minus x, minus 12 times 4, 48, and for y prime, right, not to the first prime, it's x minus y plus 2 times, right, because a half times 4 is 2, 2 times 100 minus y, it's 200 minus 2y. So let's add like terms, and we get 4x prime equals negative 2x plus y plus 52, and 4y prime equals x minus 3y plus 200. Now, if I want to solve this system like we did in college algebra maybe, to eliminate something, let's not forget we have x, y, x prime, y prime, we have 4 unknown values, and we have just 2 equations. So we're gonna use some operators to have only 2 variables in here. So the operator that I'm gonna use is d. So instead of x prime, which actually means dx dt, I'm gonna use this notation, d applied to x. So basically this whole thing, d over dt, I'm gonna rewrite it using d, so I'm writing that it's applied to x, and the same procedure is for y prime, which actually means dy dt. I'm gonna write it as this, I'm gonna replace it with a d, and I'm applying it to y. So what we're gonna get is 4d applied to x, and then plus 2x minus y equals 52, and the bottom is negative x plus 4d applied to y plus 3y equals 200. And the next thing is connect these two together. So I'm going to write 4d plus 2 applied to x, just to compress it, all the x's together, minus y equals 52, and negative x plus 4d plus 3 applied to y, not multiplied by applied, because it's an operator, equals 200. So now we have just 2 variables. We have x and we have y. So we can use elimination. So I'm going to eliminate x to find y. So to do that, I'm going to multiply, or basically apply 4d plus 2 to all the sides of my equation, of the second equation. So the first equation is 4d plus 2. We are using the same procedure as we did in college algebra when we were eliminating, only this time we are applying an operator. 4d plus 2 applied to x plus 4d plus 3 times 4d plus 2. It's commutative, so I can put them like that for this specific case. And now we can add the terms. So the ones in x are gone, and now the y's, it's 16d squared plus 20d plus 6 applied to y minus y equals 52 plus, now d applied to 200 is basically the derivative of 200 is d dt of 200, so the derivative of 200 with respect to t, which is 0, and then we got 2 times 200, which is 400. So we applied this 4d, and then we multiply the 2 with 200. So we obtain 16y double prime plus 20y prime plus 6y minus y equals 452. Of course, I'm not going to use the d anymore because it's much simpler to use the equation in this format. So 16y double prime plus 20y prime plus 5y equals 452. This is a non-homogeneous second order differential equation. So let's solve it. First thing, we are going to find the general solution. How do we find the general solution? Or let's say finding the general solution. We are going to set our equation equal to 0 to find the solution of the homogeneous equation. And let's not forget the type of solution, y of t, is e to rt. And if you actually replace that y prime and y double prime, you're going to end up with 16r squared plus 20r plus 5 equals 0. This is the auxiliary equation. So how do we solve it? Well, quadratic formula. So if you use quadratic formula, you then end up with r1 and r2 equal to negative 5 plus minus square root of 5 over 8, which is two real distinct solutions. So what does that mean? It means that the general solution is c1 e to negative 5 minus square root of 5 over 8t plus c2 e to negative 5 plus square root of 5 over 8t. This is the general solution. Now let's try to find the particular solution. Well, for particular solution, we learn two methods. We learn the non-determined coefficients and we learn variation of parameters. Just because the function after the equal sign, it's an easy one, it's a constant, we kind of expect to have to be able to use the undetermined coefficients with no problems. So we are looking for yp, the particular solution of the form some constant, which we are gonna find out. So basically, yp prime of t is 0 because it's a constant, and yp double prime of t equals 0 as well. So replacing all this into this equation, right, in my non-homogeneous, in equation star, we obtain 0 plus 0 plus 5 times a equals 452. So basically a equals 452 over 5. So we have that our general solution is this form, and our particular solution, which was of the form equals a, is going to be 452 over 5. So we have the general solution and we have the particular one. So the solution of the system for y of t, it's c1 e to negative 5 minus square root of 5 over 8t plus c2 e to negative 5 plus square root of 5 over 8t plus 452 over 5. So now that we have y of t, how can we calculate x of t? So we want to find x of t. So how do we do that? Well, if we go back into our system towards the beginning, I have these two equations here, which are in the simplest format, but they are not using yet the operator. So they are the best candidates to find our x. Now, if we take a look at the first equation, we want to find x. We know y, so we would know this piece. But then if we replace y, we'll end up with x prime as our unknown and x as our unknown. While if we take a look at the second equation, we know y, we can differentiate y to have this part here, so we can find x right away from this equation. So our second equation, it's one that is going to be helpful to find x. So let's rewrite it. So for y prime equals x minus 3y plus 200. So basically x of t, right, just for to have easier notations, we wrote just x and y, but we know they are functions of t. So x equals 4y prime plus 3y minus 200. So in order for us to calculate this, we will need to calculate y prime of t. We have y of t, so let's calculate y prime of t. So please pause it, calculate it yourself, and then let's meet back here. So we found y prime of t to be negative 5 minus square root of 5 over 8c1 e to negative 5 minus square root of 5 over 8t plus negative 5 plus square root of 5 over 8c2 e to negative 5 plus square root of 5 over 8t. So x of t is going to be equal to 4 times this. So 4 times that is negative 5 minus square root of 5 over 2 c1 e to negative 5 minus square root of 5 over 8t plus negative 5 plus square root of 5 over 2 c2 e to negative 5 plus square root of 5 over 8t plus 3y, so plus 3, and now I put the purple equation, so plus 3 c1 e to negative 5 plus minus square root of 5 over 8t plus 3c2 e to negative 5 plus square root of 5 over 8t plus 3 times 452 over 8, this would be 3y, minus 200. So x of t, we can do a little bit of algebra to make it a little bit nicer, but this is it. This is x of t. And I simplified it here. I actually computed this one because they are like terms with this one and this piece here with this piece, and this is x of t. So x of t and y of t were computed. I hope it helps.